Our lesson today is on adding and subtracting radicals. So to combine radicals, the index, which is A, and the radicand, which I label B, must be the same. So in this right here, I just labeled the index A and the radicand B. So the index and the radicand inside here, both of these need to be the same in order to combine, to add or subtract. So if they're the same, you can add or subtract. If not, you can't combine the two radicals. So think of radicals as variables to solve. So for example, if I'm given something like this, 3 plus the square root of 5 plus the square root of 7 plus 2 plus 6 square root of 5, I can think of it like this. 3 plus A, I'm just going to substitute, I just picked random variables, A and B. So I'm going to say 3 plus A, and I'm going to so I called the square root of 5 A, and I'm going to call the square root of 7 B. Okay, so every time I see a square root of 5, I'm going to call it A, and every time I see a square root of 7, I'm going to call it B. So 3 plus A plus B plus 2 plus 6A. Okay, so what could I combine there? Well, 3 plus 2 we know is 5, right? And then A plus 6A is 7A. And then we just have a B left. So that's how we combined it usually, right? Well, in the same way, I can look at this and say, okay, well, 3 plus 2 is 5. The square root of 5 plus 6 square root of 5, notice here when we add variables, A plus 6A is 7A. It's the same thing. This is like 1 square root of 5 plus 6 square root of 5 is 7 square root of 5. And then plus the square root of 7 because there's no other radicands that have a square root of 7. And then that would be your final answer. So that's how you add and subtract. Now, you see how in this one there's a 20. Is there any way we can break that down smaller? So if we were to look back up at this example up here, 5 and 7, those are called prime numbers, which means we can't break that down, right? But we can break down 20. So 20 we can look at as 4 times 5. I'm going to circle the 5 because I can't go anymore with that. And then the 4 can break down into 2 times 2, and I'm going to circle each one of those. So now I have a pair. Remember, the index up here is a 2 if there's nothing there. So since the index is 2, it tells me to group pairs, groups of 2, right? So I'm going to take one of those out, and what's left under my radical? Just a square root of 5. Okay. And then I'm just going to bring down plus square root of 5 minus 6 square root of 5. Now, notice how all three of the radicands are the same. So we can combine. Well, 2 plus 1 minus 6 is negative 3. And then square root of 5. And that's our final answer. Okay, so let's do another example over here. So can I break down 12? I can into 3 and 4. And then I can circle the 3 because I'm done with that one. 4 I can break down into 2 and 2. I'm going to circle both of those. The index here is a 2, so I can circle both the 2's. And notice how I bring 1, 2 out. I leave that 3, the extra 3, I leave that inside. And I'm going to bring that negative 3 down in front because remember that was there at the beginning. I'm going to multiply it by that outside 2. And that 2 again I got here. And then 27 can be broken down into 9 times 3. I'm going to circle the 3 because I'm done with that. And then 9 I can break down in 3 times 3. And then that index here is 2, so I can circle the pair of 3's there. I'm going to bring one of them out and leave the other 3, the extra 3, on the inside here. And then I'm going to bring that 7 down and multiply. So on the left-hand side, I have negative 6 square root 3 plus 21 square root 3. They both have a radicand of 3, so I can say negative 6 plus 21, which is a positive 15, square root 3. And that's my final answer. Okay, so we're just doing a bunch of examples. So this one, the 7 here is prime, right? We can't break that down anymore, but 175, I know I can divide that by 5, but I guess I also tried 25 in this case. So 25 times 7, the 7 you're done with, and the 25 splits down into 5 times 5. Okay, and it tells me to take out a pair because the index is 2. So I'm going to take 1 5, put it on the outside, and my leftover is a 7. I'm going to leave it on the inside. I'm going to bring that first term down because I couldn't do anything extra with that. And then the radicands are the same, so 3 plus 5 is 8, square root 7. That's your final answer. Okay, what if we have variables under the radical? So if we have variables, we touched on this last time. So if you were in class last time, we did talk about this, but we're going to go into it in even more depth today. So we divide the exponent by the index. If it doesn't go in evenly, the remainder stays inside the radical. Okay, well, what does that mean? Let's look at a couple examples. So we divide the exponent. Remember, this is called an exponent, that 8. We divide it by the index. And remember, the index here is 2 if there's nothing there. So we say 8 divided by 2. Their answer then is x to the 4th. Okay, here we have 2 variables. So we're going to say, remember, there's a 2 there. There's an automatic 2 if there's nothing there. So 6 divided by 2 and y to the 10 divided by 2. Well, 6 divided by 2 is 3, and 10 divided by 2 is 5, so that would be your final answer. Okay, so this time it has an index of 3, so it's 15 divided by 3, which is x to the 5th. Makes sense? So now, if it doesn't go in evenly, like you see how this is a 7, and we're going to divide by 2, because there's a 2 there for the index. So 7 divided by 2. That doesn't go in evenly. It is x to the 3rd, right? Because 7 divided by 2 goes in 3 times, and we have a remainder of 1. So we're going to put that remainder of 1 on the inside. So we know x to the 3rd comes out. That's x to the 3rd stays on the outside. And then we have square root of x to whatever the remainder is. So this time the remainder was 1, so we're going to say x to the 1st power, x to the 1. If that was a remainder of 2, we would say x squared. You don't have to put that 1. If you just put x by itself, that is your, oh, I guess I wrote it here. Then you could do it either way. So you could say x to the 3rd square root of x to the 1st, or x to the 3rd square root of x. Those are the same thing. Okay, so now if we have 2 variables, we say, okay, well, x to the 11 divided by 3, because the index here is 3, and y to the 5th divided by 3. Well, 11 divided by 3 is 3, and you have 2 left over, remainder 2. And 5 divided by 3 is also 1, remainder 2. So that means we have x to the 3rd on the outside, y to the 1st on the outside, and then x squared, y squared on the inside because of that remainder. Oh yeah, and don't forget, if you started with a cube root, like that 3 right here, you have to still have that 3 in your answer, so make sure you remember to do that. Okay, so let's put it all together with numbers and variables. So here, we're going to take a look first at the number 8. Okay, so 8 breaks down into 4 times 2. I'm going to circle the 2 because it's prime, and I can continue to go with 4. So 4 breaks down into 2 times 2. Now you see the index here is 3, so we have to group groups of 3 here. So we have a group of 3 2s that make 8, right? So I'm only going to take one of those pieces out. Now I'm going to look at x to the 4th. Okay, and by the way, there's nothing left inside, right? Because we took 1 2 from here, and there's nothing left. There's no other numbers that make up 8 but 2 times 2 times 2, and we needed 3 of them, so we only have 1 on the outside. X to the 4th, remember we do 4 divided by 3, and that's going to give us 1 remainder 1. So 4 divided by 3 is 1, and then we have a remainder of 1 left over. So I'm going to put my x to the 1, this x is going to go on the outside, and then inside is going to go this remainder 1x, right? So x to the 1st, or just x on the inside. And then y to the 6th, we're going to do y to the 6th divided by 3, and that comes out evenly as y squared, and we put that on the outside. There's nothing left inside. There's no remainders. So I just simplified this entire thing and made it this. That's the most we can simplify. Now we go on to this next one. So I'm going to erase this part so I have room. So I'm going to bring the 3x down so I don't forget about it. But I'm going to look on the inside here. Now look at x. X cannot be broken down at all. It's just a 1 inside, right? So I'm going to leave that inside the square root or the cube root because I can't break this down. Like if this is x to the 1, I can't group 3 x's if there's only one x to start with. So I'm just going to leave that underneath here. Okay, y to the 6th. I can divide that by the index. So it's y to the 6th divided by 3, which is y squared. And that goes on the outside here. There's nothing left inside. Now let's simplify this one. So I'm going to bring minus 4y squared down because that's on the outside. And all I have is an x to the 4th here. So 4 divided by 3 is 1 remainder 1. That means I have 1x on the outside and I have 1 on the inside. Okay, so now I'm going to bring down, so all I did from this step to this step, I rewrote this exactly the same, rewrote this exactly the same, but you see how I switched the x and the y here? The reason I did that was because x comes before y technically in the alphabet, so that's like the standard form to write it, and also notice here it goes x and y, xy squared, xy squared, xy squared. So I just wanted to write it in that order, and we can do that with multiplication. We can flip-flop things around, right? Now, are all the radicands the same? Yes, and all the indexes are same. 3, 3, 3, and then x, 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 which means we can add everything here on the outside. So 2 plus 3 is 5, and 5 minus 4 is 1, xy squared. Remember, I keep these the same when I add, just like I keep these guys the same when I add and subtract, right? So all I'm looking at is the numbers. 2 plus 3 is 5, 5 minus 4 is 1, xy squared, and then I keep this the same too, cube root of x, and that's your final answer. Okay, let's do another example. We just have a couple more. So look at this 16 in the inside. We could break that down into 8 times 2. I'm going to circle the 2. We could break the 8 down into 4 times 2. I'm going to circle the 2. 4 is 2 times 2. I'm going to circle both those. The index here is a 2 because there's nothing there, so I have to circle groups of 2. Okay, so there's one group of 2, another group of 2. So notice I'm bringing the 3 down in front. I'm going to take 1, 2 from this and 1, 2 from this. So this time I'm multiplying 2 different 2's on the outside because I take 1 from each group that I circle. And all that I have left inside is the square root of x. Remember, if there's not at least the index amount inside, we can't take any out because if there's x to the 1st, I can't take out 2 x's if I only have 1. So I just leave that inside. Okay, so 3 times 2 times 2 is 12, square root of x. Now I'm going to look at the 100. So 100 breaks down into 10 and 10. Now, you could keep going with this, but if you notice, hey, 100 breaks down into 10 and 10. Just like if you notice that 16 breaks down into 4 times 4, you could circle the 4, because didn't we technically take out a 4 here? So you could keep going down 5 times 2, 5 times 2, and you'll get the same answer. But if you notice that 100 is like, oh, okay, well, that's 10 times 10. I'm just going to take this out right away. You could just take out a 10. And then you just have the square root of x left over. Just like 64, if you're like, oh, that's 8 times 8, circle the pair, because you know you need a pair. You know you need 2, right? So you're going to circle that. You could take the 8 out, bring the 5 down, take the 8 out, and you just have an x left inside. 5 times 8 is 40. I put plus because there was a plus here, right? I put minus because there's a minus here. And then square root of x, all of the indexes are 2, 2, 2, 2, and all the radicands are the same, so we can combine 12 minus 10 plus 40 is 42, square root of x. Oh, oops, sorry, that went too fast. And that's your final answer. You box this. Okay. So, 4 square root of 3 plus 48. Square root of 3 you cannot break down, but 48 you can. So 48 you can break down into 3 times 16. Okay, I'm going to circle the 3. 16 is 4 and 4. Again, you can keep going with 4, but since you see, Okay, I did keep going. So if you wanted to just circle these right away, that's fine. But you could say, okay, 2 and 2, 2 and 2. So I know I need a pair, right, to take out. So I have take out a pair of 2s, another pair of 2s. So I'm just going to rewrite that guy because I couldn't do anything with 4 square root of 3. Plus, so I'm going to take a 2 out from here and a 2 out from here. And I have a square root of 3 left inside. So 4 square root of 3 plus 4 square root of 3 equals 8 square root of 3. Okay, I believe this is the last example. So here we can break down 64. Let's start with the numbers. So 64 can be broken down into 8 times 8. Since I know I only need to take 2 out because the index is 2, I'm just going to say 8 times 8 and circle that right away. X to the 4th. Remember, you take this and you divide it by the index, so 4 divided by 2 just comes out evenly as x squared. So I'm going to circle that because I know I need that on the outside. And see that y, again, there's only one y. We need to take out 2 in order to take it out of the square root, so I'm just going to leave that guy on the inside. So I take out an 8. I take this x squared, I tack it on the end because I know 4 divided by 2 is x squared. I didn't have any left inside, so that comes out. And then don't forget about that y up there. That y needs to come down. You do have something left in the square root. You have that y, so I'm going to bring down that y there. Okay, I'm going to look at this y cubed. 3 divided by 2, again my index is 2, is 1 remainder 1. So I have 1 y to the first power, or y on the outside, and I have 1 y left on the inside. So I'm going to bring down the 3x squared. I know I have 1 y on the outside, and I have 1 y left on the inside. So you see how again, the indexes are the same, they're 2, and then the radicands are the same, they're both y. So that means I can combine these. So 8 plus, and I can only combine these because 8x squared y and 3x squared y. So x squared y and x squared y, both of those are the same, which means I can combine 8 and 3. If this was 8x cubed y and 3x squared y, I cannot combine these two, even though the square root of y is the same. Because in order to combine these two, I need to have every single variable match every single variable over here. Okay, so that's really important. So since x squared y is the same as x squared y and square root of y is the same as square root of y, I'm safe. So 8 plus 3 is 11. X squared y, remember we do not change, we don't add these, we just keep them the same, x squared y. Square root of y stays the same, and that is your final answer.